Let's look at this question. Madhuban Society has 3-level parking, P1, P2, P3. Total 525 vehicles, namely bicycles, bikes, and cars, were parked on the 3 parking levels. If a parking level has both bicycles and bikes, at least one car is parked on that level. Okay. So based on this, so far, there are 3 parking levels, P1, P2, and P3. And we have bicycles, we have bikes, and we have cars. So a 3x3 matrix of this nature will get created. I should also make total possibility. I know total is 525. So we have this. Now this instruction you will follow. If a parking level has both bicycles and bikes, at least one car is parked on that lane. So whenever I have both bicycle and bikes, cars have to come. Okay. The total number of vehicles on P1 is same as on P3, which is 30 more than the number of vehicles on P2. So if this is X, this is X, this is X minus 30. We know the total is 525, so we can figure out value of X. 3x minus 30 is 525, or 3x is 555, or X is 185. Okay. So here we have 185 vehicles, here we have 155 vehicles, and here we have 185 vehicles. This is known. Okay. Up until here we have done understanding. There are an equal number of bicycles and bikes on the 3 levels taken together. Bicycle and bikes, they are equal. So let this be y, let this be y. The summation of the columns are identical. Bicycles parked on P1 and P2 taken together. Bicycles parked on P1 and P2 taken together are 55 less than the total number of vehicles parked on P2. Total number of vehicles parked on P2 is 155. So 55 less than that. These two regions add up to 100. Okay. This is also done. The number of bicycles on P1 is same as the number of bikes on P3. So if this is A, this is also A. This region here will turn to 100 minus A. Okay. The number of bicycles on P1 is same as the number of bikes on P3. The difference, okay, this is done. The difference between the number of bikes and bicycles on P2, is equal to the number of bikes parked on P1. So if I have B here, I'm introducing a new variable because that was needed. If I have B here, the difference between these two would either be 100 minus A minus B, assuming the number of bicycles was greater, or it could also be B minus 100 plus A. Both of these possibilities exist. Because both of these possibilities exist, I am going ahead and creating a separate table where the second possibility will be recorded. So I have P1, I have P2, and I have P3. And I have bicycles and bikes and cars. All the information that is guaranteed will be copied as is. Only the final expression for bikes on P1 needs to be edited. So this is A, this is 100 minus A, this is Y, this is Y, this is A, this is B, this is B plus A minus 100. Let me also erase this. This bottom case is what I recorded in the right there. I have 525 I have 185, I have 155, and I have 185 here. Okay. Now, look at the total of bikes. Look at the total of bikes. 100 minus A minus B plus B plus A. So the total here should be 100. If the total here is 100, both these parts were supposed to add up to 100 only. So both these parts were supposed to add up to the same number. So this is also 100. So if this is also 100, these two spots anyway were adding up to 100. P1, P2 for bicycles were adding up to 100. So this has to be 0. This is known. And what else? So this here will be, okay, this will be 325 then. 100, 100, 325 and 525. This will work. Then what do we have here? This is 0. This is A. This will be 185 minus A. Okay. And here 100 minus A plus A. So 100 minus B I've got. So this will be 85 plus B. This will be 85 plus B. Okay. Now this last region, I can represent it in wonderful ways. We can represent it in wonderful ways. See, if I look at it row-wise, row-wise, right now I have 100 minus A plus B. So it should be 55 plus A minus B, so that the entire O row adds up to 155. Column-wise, it should add up to 325. So what should this be equal to? Trying to figure out. Let's see. 85 plus 185. 85 plus 185 is 270. 270. So I'm still getting 55 plus A minus B. Still, yes. Both these cases, I'm getting the same expression, which tells me that the table I have created so far, for the last cell, I can do this work. The table that I've created so far is sensible, row-wise and column-wise. Everything makes sense. Okay. Now let us continue the work in the second one. Can I do something here? I can do it for the first row. You can do it for the first row. I have minus 100 here. So lots of work. I will have 285 something. Can't really do it. Here I was able to run away with it because 100 was available. Summation of bikes came out to be 100. Therefore, we could do all the work. For the case at the bottom, we can't really do anything right now. Or maybe we can. See, B plus A minus 100. B plus A. So Y is as good as 2B plus 2A minus 100. So here also I should be getting 2B plus 2A minus 100, which would also tell me that these two currently add up to 100. So this should be 2B plus 2A minus 200. This can be defined. Now the expressions for cars, I can come out with them. I can have expressions for cars, but then all of them will have A's and B's involved. And I'll wait till I'm done with all the instructions. But this idea, the difference between the number of bikes and bicycles on P2 is equal to the number of bikes parked on P1. This gives me two possible cases. It has to be accounted for. Okay. At least one parking level does not have any bicycle. But all the parking levels have bikes as well as cars. So bikes as well as cars should be present on all levels. But there is at least one level on which there are no bicycles. Okay. For the first case, we already have that determination. Because bicycles in P3 are already 0. Now, in the second case, where can bicycles be 0? If the first case is 0, then bikes will also be 0 somewhere. So this A cannot be 0. 2b plus 2a minus 200. If this is 0, a plus b will be how much? If 2b, let me see p3. If on p3 I get 0, 2b plus 2a minus 200. If this is equal to 0, so 2b plus 2a is 200, or a plus b is 100. If a plus b is 100, then bikes on the first level will turn out to be 0. And bikes, I cannot have bikes 0 anywhere. Bicycles can be 0 somewhere. So this cannot be 0. P1 count of bicycles cannot be 0. P3 count of bicycles cannot be 0. So only P2 count of bicycles can be 0. For this to be 0, as A has to be 100 itself. This is 100. And this is 100. And now we were told this minus this gives me the count of bikes here. This minus this gives me the count of bikes here. B plus A minus 100. So this will turn to simple B. This will turn to simple B. A is turning out to be 100. So this will turn to 2B. I'm much happy. I'm very happy. A as a variable is out of running altogether. This will turn to 2B plus 100. This will turn to 2B plus 100. Let me write down the expressions appropriately. I can even get rid of these y's. They are no longer of any use. So I have 2b plus 100 and I have 2b plus 100. 100 gone. So this should be 325 minus 4b. This is another case generated. Now here I should have 85 minus b. Here I should have 155 minus b. And finally I should have 85 minus 2b. Column wise it should be 85 minus 2b, and row wise also it should be 85 minus 2b. So the work that we have done in the table is sensible. The work that we have done in the table is sensible. So these are the two possible cases. These are the two possible cases. In the first case, both A and B can assume some value. Both A and B can assume some value. But the second case has been reduced to a single variable B, which makes our life very easy to deal with. Let's get to individual questions. What are they asking? If the number of cars parked on P1 is same as the total number of bikes, number of cars parked on P1 is equal to total number of bikes. So essentially they are saying, in first case, if first case is valid, 85 plus B is equal to total number of bikes, 100, or B is equal to 50, which is fine. So far it seems fine. In the second case, total number of bikes here is 2B plus 100, and here it is 85 minus B. So 85 minus B is equal to 2B plus 100, or 3B is equal to minus 15. B is the count of bikes. That cannot be negative. So the second case is not even valid. Only the first case is valid, and B is equal to 15. This is where we have to work. Okay. If the number of cars parked on B1, parked on P1 is same as the total number of bikes, then how many bikes were parked in P2? In P2, bikes parked are B. B is 15. So answer has to be option A. Next, how many vehicles were parked on P1? 185 vehicles were parked on P1. This was something we had asserted long ago. Next, if the number of cars parked on the three levels, P1, P2, and P3 are in the ratio 4:3:6. 4:3:6. How many bikes were parked on P3? How many bikes were parked on P3? So they're essentially asking value of A. Okay. Right now I see in case 2, in case 2, see, I've stored number of cars parked on P1 and P2 is in the ratio 4:3. But with the number of cars in case 2, number of cars parked on P1 and P2, the first number will be smaller than the second number. 85 minus B always will be lesser than 155 minus B. So it is not the second case being talked of. It is the first case being talked of. If it is indeed the first case being talked of, that is wonderful because the total here I already know is 325. So that divided into 13 parts, 4 plus 3 plus 6 is 13. That divided into 13 parts is 25 each. So we get 100, 75 and 150 to deal with. 100, 75 and 150 to deal with, which means 185 minus A. See, finally what I need is bikes parked on P3 or I need the value of A. So 185 minus A is 150 or A is equal to 35. Answer to this question will be option A. So nice, both the cases are useful for us. Finally, if the number of cars parked on 3 levels, P1, P2 and P3 are in the ratio 4:3:6. Okay. 4:3:6. Again, it will not be the second case, it will only be the first case. So essentially, the entire framing of the second case is proven to be useless because everything is coming from the first case only. If the number of cars parked on 3 levels, P1, P2, P3 are 4:3:6, find the number of bicycles parked on P2. See, because this is the last question, we've already figured out. This is 35, this is 150, this is 75, and this is 100. So B is 15. So this is 50. This is 65. This is 35. All the numbers that we need are known. They've asked me find the number of bicycles parked on P2. Bicycles on P2 is 65. So the answer will be option D. And that is the entirety of the set. When we reach the last set, we can populate the table because no more processing is needed. That will be all.